Next question says there are only red counters and yellow counters in bag A. Number of red counters to number of yellow counters is 3:5. There are only green counters and blue counters in bag B. The number of counters in bag B is half the number of counters in bag A. Given that there are X red counters in bag A, use algebra to show that the total number of counters in bag A and bag B is 4x. Okay, so let's start with the red is to yellow ratio. So that's 3:5, which means if we use the red one, red is basically 3/8 of total. Total count is for A, so I'm going to write total A. So red counters are given as X. So X is 3/8 of total A. So which means if we make total A the subject, so that's going to be 8x over 3 equals to total counters in A. Okay. The number of counters in B is half the number of counters in A. So total B is going to be 8x over 3 divided by 2, which is 8x over 3 times 1 over 2, and that is 4x over 3. So they're asking us to show the total number of counters in A and B is 4x. So if we add 8x over 3 and 4x over 3, that is 12x over 3. And if we simplify 12x over 3, that equals to 4x, which is exactly what they're asking us to prove. So that's your answer. Next question says, at the start of 2022, Kim invested some money in savings account. The account paid 3.5% compound interest each year. At the end of 2022, interest was added to the account. Then Kim took £750 from the account. At the end of 2023, interest was added to the account. Then Kim took £1,000 from the account. There was then £2,937.14 in the account. Work out how much money Kim invested at the start of 2022. You must show all your working. So for this, first I'm going to assume that this amount that you started with in 2022 is X. Okay. So we find the compound interest in 2022. That's going to be X, which is our principal amount, times the rate of interest is 3.5. So 1 plus 3.5 over 100 to the power of 1, because we're talking about 1 year from 2022 to 2023. So that gives us 1.035x. 3.5 divided by 100 is 0.035. Add 1, so that becomes 1.035, and you times it by x. At the end of 2022, Kim took £750 from the account. So end of 2022. That's going to be 1.035x minus 750. So that means when we start 2023, this is going to be our initial amount. So compound interest in 2023 will have the initial amount as 1.035x minus 750 times, again, 1 plus 3.5 over 100 to the power of 1, because we're still taking in account 1 year, not more than that. So this will give us 1.071112x minus 776.25. So now at the end of 2023, she's taking 1,000 from the account. which means we'll subtract 1,000 from this amount. So end of 2023, we have 1.0712x minus 776.25 minus 1,000, which leaves us with 1.0712x minus 1,776.25. This is the amount that she has at the end of 2023. So they say that there was then 2,937.14 in the account. So this amount at the end of 2023 equals to this. So if you put these two equal, we get an equation where the only unknown is x. So we can find the value of x using this minus 1,776.25. So we add the two. Equals to 1.0712x. So that is going to give us 4713.39 equals to this. And then we divide both of them. And that is going to give us 4,400 pounds as the initial amount when we started investing in 2022. In case in the exam you come across a similar question and you're confused about your value, what you can do is you can use your answer that you get, like for x, you can reverse the question, start using that value and do everything on that value that's given the question. You find the compound interest for each year, subtract the value, then use that new value and find the compound interest again, and then subtract the value. And after doing all of that, if you reach to the value that is given, that should be at the end of 2023, then your answer is incorrect. But if your value doesn't match, then you probably made a mistake and need to redo the entire thing. So this is a trick that you can use to easily check your answer for these type of questions. Just reverse the question, use your answer and do everything again. And if it works, you're good to go. Question 17 says a ball is thrown upwards and reaches a maximum height. The ball then falls and bounces repeatedly. After the nth bounce, the ball reaches a height of hn. After the next bounce, the ball reaches a height given by hn plus 1 equals to 0.55 times hn. After the first bounce, the ball reaches a height of 8 meters. What height does the ball reach after the fourth bounce? So basically, h1 is 8. So if h1 is 8, when n equals to 1, so over here it's going to be h2 equals to 0.55 times h1, which is 0.55 times 8, and that is going to give us 4.4 meters. Now we can use this to find h3, which is going to be 0.55 times h2. So 0.55 times 4.4, that is going to give us 2.42 meters. So similarly for h4, which is what they're asking us to find, the height after the fourth bounce, we multiply 0.55 with h3, and 0.55 times 2.42 will give us the value of 1.331 meters. That is your height for the ball after the fourth bounce. Question 2 says x minus 4, x plus 2, and 3x plus 1 are 3 consecutive terms of an arithmetic sequence. Find the value of x. So when we have an arithmetic sequence, that means there's a common difference between each term. So the difference between x plus 2 and x minus 4 is basically the same as the difference between 3x plus 1 and x plus 2. So that's x plus 2 minus x plus 4 which is 6. We have 3x plus 1 minus x minus 2, which is 2x minus 1. So since the difference is common, so that means 6 equals to 2x minus 1. 6 plus 1 over 2 equals to x, which is 3.5. That is your answer. Then in part B, it says y minus 4, y plus 2, and 3y plus 1 are 3 consecutive terms of a geometric sequence now. Find the possible values of y. So when we have a geometric sequence, we have a common ratio. So common ratio is going to be the division of 2 consecutive terms. So y plus 2 divided by y minus 4 is the same as 3y plus 1 divided by y plus 2. 2 consecutive terms being divided, the bigger one being on the top, will give us the same ratio as that between any other 2 consecutive terms in the sequence. So that means these two are equal to each other. Cross multiply. We have y plus 2 squared equals to 3y plus 1 times y minus 4. Y plus 2 squared is y squared plus 4y plus 4. And this is 3y squared minus 12y plus y minus 4. So y squared plus 4y plus 4 equals to 3y squared minus 11y minus 4. Collect all the terms on one side. So 3y squared minus y squared minus 11y minus 4y minus 4 minus 4. That's 2y squared minus 15y minus 8. So now we factorize this quadratic equation. So 2y squared minus 15y minus 8. If you multiply 2 and 8, that's 16. Factors of 16 are 2 and 8, 4 and 4, 16 and 1. Since our middle term is 15, we know 16 minus 1 is 15. So we can replace 15 with negative 16y plus y minus 8. Between the first two terms, we have 2y common. So y minus 8. And between the last two terms, we have 1 common. So again, y minus 8 inside the brackets. Between 2y and plus 1, we have y minus 8 common. So y minus 8 times 2y plus 1. One value y is 8 and the other value is negative 1 over 2. These are your possible values of y. Question number 21. The diagram shows a circle radius r centimeters and 2 regular hexagons. Each side of the large hexagon ABCDEF is a tangent to the circle, and each side of the smaller hexagon PQRSTU is a chord of the circle. By considering perimeters, show that pi is less than 2 root 3 but greater than 3. Okay, so this is a slightly tricky one, but if you just break it down, honestly, it's not that difficult because at the end of the day, they've given the answer in the question. So if you just like manipulate the question, you can reach the solution. So let's begin with understanding the formulas that we'll use. We know that for the hexagon, it's a regular hexagon, so which means all lengths are equal. So if this is A, this is also A, this is also A, this is also A, this is also A. So perimeter of the hexagon is going to be 6 times A. Same for the outer hexagon, the perimeter is going to be 6 times whatever the length is. For the circle, the circumference of a circle is 2 pi r. They have said that the radius is r centimeters. So if we draw the radius, these two lines represent the radius because we're coming from the center. This is R and this is R, and we're going towards the circumference. Now, if it's a regular hexagon, if we divide the hexagon into 6 equal triangles, we can clearly see that all of these are going to be 60 because 360, which is the angle of a complete circle, divided by 6 is 60. So these are 60. This is R, this is all of these are R as well. Now, if we find these two angles, we know that the radius is the same for each length. So it's an isosceles triangle. So for angle P, if we do 180 minus 60 divided by 2, that also gives us 60, which means that these are all equilateral triangles inside the hexagon. So using this, we can say that this length is also going to be R. Because if the angles are equal, they're all 60. It's an equilateral triangle, so the lengths are also going to be equal. For the small hexagon, the perimeter of PQRSTU is going to be 6 times R. Because the length is R for this hexagon. Okay, so right now we have the formula for the circumference. We have the perimeter for the smaller hexagon. Now for the large hexagon, I'm going to erase all of this. So if we draw a line from over here, this is our center. From the center towards the hexagon. So we know that the hexagon that is outside the larger hexagon, it's a tangent to the circle. Now the angle that the radius makes with the tangent is 90. This is a 90 degree, okay? So it's a 90 degree. If I draw a line from here to here, this is a right angle triangle. This line is going from the center towards the circumference of the circle, which means this is R. Okay. And we already said that if we divide the shape, once again, this is also regular hexagon. If I divide the shape like this into equal triangles, we can once again see that we're getting 6 triangles. 1, 2, 3, 4, 5, 6. And if we divide the angle, 360 divided by 6 is 60. So if this entire angle is 60, this is 30. So if I highlight this right angle triangle over here, that I'm trying to focus on this, we can see that this would be 60. So if we draw this separately over here, it's a special right angle triangle. 90, 30, 60. So this length is given as R. We know that. So in a 30 to 60 to 90 ratio, we know that this is going to be double of R. We don't know what this is, but since the 60 length is given as R, so that means 30 length is going to be R over root 3. Because in a special right angle triangle, the ratio of lengths are for this x to x root 3 is to 2x. But since there is no root 3 with the 60 length, so that means the 30 length is getting divided by root 3. Okay. And for 90, that's going to be twice of that. So that's going to be 2r over root 3. So which means this length over here that is r over root 3, half of AB basically. So if half of AB is r over root 3, that means this is going to be r over root 3 as well. So the entire length AB r over root 3 times 2, that's 2r over root 3. So to find the perimeter of A, B, C, D, E, F, we times 6 by 2r root 3, which is 12r root 3. So we have an expression for all three. For the circumference, it's 2 pi r. For the smaller hexagon, it's 6r. And for the bigger hexagon, it's 12r over root 3. So now I'm going to use these to create this inequality and then solve to get the final answer as given in the question. So the bigger hexagon, 12r over root 3. In the middle, we have the circumference, 2 pi r, and the smaller one, which is 6r. So to turn this into this, we have to rationalize this third. So to rationalize this third, we're going to multiply and divide it by root 3. So 6r, 2 pi r, and this is going to be 12 root 3r divided by 3. 3 ones are 3, this is 4. So 6r, 2 pi r, and that is 4 root 3r. We can see r is found between all three, so the r gets cancelled out. Over here we have 3, over here we have just pi, so that means let's divide all 3 by 2r because this is what's not present over here. So 2r divided by, so 6r divided by 2r is 3. 2 pi r divided by r, 2r is pi. 4 root 3r divided by 2r is 2 root 3. And this is exactly what the question was asking us to prove. I know it looks very confusing, like if you just, for the kids who saw this like the first time in the exam, but like you just need to break it down. You need to find expressions for all three separately. For the smaller hexagon, it's very simple, like you saw, like it was the same length because it was an equilateral triangle between each. So you found r as the length for the smaller hexagon. For the circumference, very simple because they've given the radius as r, so you just put it in the formula. For the bigger hexagon, it was slightly difficult, but you could have still used the same. You could even use the equilateral one over here as well. Like made AB the equilateral and use that. I just split it all like in another triangle already and then used it. But you can even use the equilateral formula on the bigger hexagon. Find your expression, find your length for AB using the special right angle triangles, and then put them in an inequality and simplify to get the same thing.